So we're going to apply the double bond naming system to the cycloalkenes. So focusing on the compound here, this would be a cyclohexane. So we got 1, 2, 3, 4, 5, 6 carbons. So this is a cyclohexane. If we were to now move on to the next compound, we would see that this is a cyclohexene. We've introduced the double bond, and this would just be called a cyclohexene. There's no need to say the number 1 carbon here because there's no other functional groups on here, so there's no need to reference it at all. When we move on and add in a second double bond, so this is now a cyclohexadiene, now we need to start indicating where the carbons are. And so if we start from 1 carbon here, 2, 3, 4, 5, 6, we can see that we've got our double bond starting in the 1 and the 3 position. And similarly, if we started from here, 1, 2, 3, 4, 5, 6, we end up with the same numbering notation. So it doesn't matter which side we start from as long as we start from the double bond. So this compound then would be a cyclohex 1,3-diene. That. So now we're introducing a third double bond into this, and this is where IUPAC tries to make things less complicated if possible. And oftentimes it's really dependent on chemistry as well. We'll find that the cycloalkane group here, being part of the alkanes, are fairly unreactive. Really, they got to go through free radical mechanisms in order to actually go through some sort of reaction. But as soon as we put the double bond on, slightly higher energy in compound, but also we can create a bit of polarity on the double bond, having negatives and positives floating back and forth. As well, the double bond can be considered a little more more electron density in it, and so it can attack positive materials and essentially act as a bit of a nucleophile in some cases. The cyclohexadiene on its part is more reactive, so it's introducing the second double bond. There's a little more strain in the molecule, and overall the energy of this system increases. So you would think by introducing the third double bond then that it would be higher in energy, and it turns out that it's not. It's actually lower in energy than its counterparts overall, and this you might recognize then to be benzene. And so rather than calling this a 1,3,5 cyclohexatriene, we just go with benzene because the reactivity of this is much different than the diene and the monoene here as well, and also different than the cyclohexane. So continuing to name some cyclohexenes, starting with this cyclohexene with the methyl group on it. We have a 1, 2, 3, 4, 5, 6 carbon continuous chain. The highest priority functional group on this is the double bond. So we're looking to start with the double bond for the numbering and then somehow include this methyl group. So if we start 1, 2, 3, we will find that we'll be able to get the lowest numbers possible, 4, 5, 6. If we were to go the other way around, start the double bond here, 1, 2, 3, 4, 5, the methyl group would be on the 5, so 1, 5 isn't as good as the 1, 3 when it comes to naming this compound. So we'll call this a cyclohexene. And I can put a 1 here. It's not completely necessary because the highest priority group is the double bond, and we need to indicate that the methyl group is in the 3 position, so it's a 3-methyl. And so the reference point really is the methyl group. So if I have a methyl group in a 3 position and I know that I have a hexene, it's automatically higher priority. It becomes the number 1 carbon, and I could redraw this. You could put the number 1 in here, and it wouldn't be any harm either to do that. So you can take it either way that you wish. On to the next compound, also a cyclohexene, very similar to the first one. The double bond is still higher priority, so we're going to start the numbering here at the 1, 2, 3, 4, 5, 6. So we can see the double bond is still in the 1 position. We have a methyl in the 3 position and in the 4 position. So we now have a 3,4 dimethyl cyclohexene, and we can indicate that it's in the 1 position, that double bond or not. So let's write this one out. 3,4 dimethyl cyclohexene. I'll put the 1 in. Again, not completely necessary because the hexene is higher priority than the methyl groups, but I tend to like to put that in there because then it's unambiguous and I don't have to guess what position it's at. So in this final one of our cyclohexene compounds, again, cyclohexene, the longest continuous chain, is 6-carbon ring. We have the double bond on here, but now we've added a different substituent. We've got the methyl group still, but we've got an alcohol or a hydroxyl. And if we look it up in the tables, we'll see the hydroxyl is higher priority. So now this gets the number 1 carbon. And so in order to keep everything low numbering, I'm going to put a 1 here, a 2, and a 3. So we'll see the position is changed based on priority of the functional groups. So again, then in the 2 position was the methyl. In the 3 position is the double bond. So I'm going to say cyclohex3ene. And now I don't have the E on the end because I have to replace that with the alcohol. And in the 1 position is the OL. So it is a 2-methyl cyclohex3ene1-ol. And I do need to indicate where the positions are now, because the alcohol can move around. It will be the number 1, and you can assume that it's number 1 here. But there are times when you have a straight chain and it can be on a 1 or a 2 position, and it is necessary for you to number it. It is not here, but you know, for safe practice, it's always good to keep that number in here, so you don't go wrong. Also, a couple of notes here. Note that I don't have the E on the end of this because the OL, the vowel in the OL, so there's no need to have the ene with the E and E at the end here. And the other thing to note too is there is no stereochemistry associated with this because these are all locked into conformation. So whenever you're on a cyclohexene, these are essentially locked into conformation, not just because of the double bond, but because of the cyclic ring. If I go to the straight chain, the conformation can be different depending on whether I've got this cis or Z conformation, or whether I've got the trans or this E conformation. So with the cyclohexenes, it wasn't necessary to indicate the stereochemistry.